Hey everybody, we are back again and we're looking at chapter 1, but we're taking a look at section 1.5, words, tables, equations, and graphs. So we're going to be looking at different ways that we can represent different ordered pairs and relations. All right, so we have the concept of a function. We have the concept of function rule that we're going to discuss, function table, and an equation. So it's not really that much vocabulary today. Let's take a look at each one. So we've got function. A function is a relation where each member of the domain is paired with exactly one member of the range. Now here's the deal. We need to kind of remember, let me see if I can get my pen to work here. Plugging it in might be helpful. Yeah, voila. Okay, so we need to remember what a relation is, right? Remember a relation from last time? It's a thought bubble over here. A relation was a set of ordered pairs. All right, so a relation is a set of ordered pairs. So if we have a relation, that relation could be considered a function if it has a specific quality, and that is that each member of the domain is paired with exactly one member of the range. So let's look at a relation. So here's a set of ordered pairs that is 2, 1, 4, 7, 6, 5, 4, 3, 7, 2. Okay? So they're talking about the domain and the range. And it says that the domain is paired with exactly one. Each member of the domain is paired with exactly one member of the range. Well, let's look at the domain really quick. What's the domain of the relation that we have here? We've got 2, 4, 6, 4, and 7. So to write this in order, I would write 2, 4, 6, 7. Remember, I don't have to repeat the values that I write in there, even if it appears more than once. And the range, let's just do the whole thing, would be 1, 7, 5, 3, and 2. So I'll write that as 1, 2, 3, 5, and 7. As I look at this, this helps me kind of look at the information that I'm giving in a different way, so I can now see what's true. So the domain is paired with exactly, each member of the domain is paired. So each of these is only mapped or matched with one member of the range. So here you see like 2 is going to 1, right? That's what that represents. And 4 is going to 7, okay? 6 goes to 5. 4 goes to 3. Hey, here's one member of the domain that's going to two different members of the range. This relation is not a function because it says that to be a function, the domain is to be paired with exactly one member of the range. So noticing that the 4 appears here and the 4 appears here tells me I don't have a function. To have a function, each member of the domain needs to be mapped with exactly one member of the range. So here's another example. I'm going to give you another example of a range relation real quick. Sorry. And I've got 1, 3, 5, 7, 6, 9, and 7, 3. So here are sets of points, sets of ordered pairs. Notice 1 is mapped to 3. 5 is mapped to 7, 6 is mapped to 9, and 7 is mapped to 3. This is a function. Even though 3 appears twice, notice that the members of the domain, right? The members of the domain here, 1, 5, 6, and 7, are only going to one member of the range. You don't have one going to two different y values. I know that was really long-winded, but this is a concept that a lot of people get confused, so I was really trying to make it clear. Let me know if you have any questions. So that's function. Function rule. So a function rule, our next vocabulary term, refers to making sure that you have a way to explain the relationship between your domain values and your range values. So is operations or operation performed with the domain value to get the corresponding range value? So for instance, if I were to give you the following, and it will be a function, watch, 2 is mapped to 4, 3 is mapped to 6, 4 is mapped to 8, and kicks and giggles 5 is mapped to 10. All right, let's say this was the relation or the function that I wanted to illustrate. And it is a function because 2 only goes to 4, blah, 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 blah. 3 only goes, right? Okay, so it is a function. And if I wanted to describe this relationship, what do I do with each member of the domain, these guys that I'm putting an arrow next to, in order to get the range, these things that I'm highlighting in yellow? What do I have to do? I think you guys all knew, well, you take the domain, you take the member of the domain, you multiply it by 2 and boom. Or somebody says you take it and you add it to itself and you get it. And both of you are correct. So what we've just created in our minds anyway is a rule, is a function rule. So the function rule can be written in this way. 2 times the input or the domain value, I'm going to put input, and I'm going to use that for each domain value, is equal to the output. All right? Or I could say, if we're looking at this as x and y, 2 times x is equal to y. All right? So the next vocabulary word is a function table, which is really super duper helpful. A function table is a list of the x coordinates, the input, as I mentioned before, and the y coordinates, the output. So if I were to make a function table like this, x, y, this would be a function table if I had, I'm going to change it up again, 2, 5, 3, 10, did I want to do that? 4, I don't know, 15. So what would the function rule be here? Well, we could figure out a rule here, but what I recognize is that this is a function table. This is a function. I see each member of the x or the of the domain being listed here as x's with its corresponding y values. All right. The final thing we're going to talk about is an equation. And equation is an important concept because it's an important concept that's often confused with expressions. Do you remember back in the day we had expressions, and expressions were like algebraic expressions specifically, so it would be like 3 plus d or 5 minus d plus, I don't know, q. So we could have all of this. But you notice that expressions, these are expressions, never have equal signs. They're just expressions. They just kind of express, you know, a concept or an amount. But an equation that we're talking about here, an equation is a mathematical sentence stating that 2 quantities are equal. So I could have 3 plus d is equal to 5 minus d plus q. And this is no longer an expression, it's actually an equation. So my idea is that equations always have an equal sign, okay? All right, let's take a look at our example. So our first example, example 1, we're going to make a function table. Make a function table with 4 input values and 4 input and output values for the following statement, then state the domain and range. So here is our statement. Our statement is going to be our rule. Triple a number, then decrease by 1. I think I can do that. All right, so we are going to make a table, x and y, input, output, and we're going to choose 4 values because they didn't specify what values we needed to do. So 3, 5, 7, and -1, just 4. Kicks and giggles make a negative number. So we're going to triple the number, then decrease by 1. So in my mind, I'm going to do this, or I can write it out. Right now, we're going to write it out, but I'm sure you guys can do this in your head. When I triple a number, that means I'm multiplying by 3. So I'm going to multiply by 3, the number, and then I'm going to decrease it by 1, subtract 1. Let me do that in green. So I'm going to then subtract 1. All right, so the green stuff that I've written is what's given by this statement. Triple the number, and then we're going to decrease by 1. All right, so let's get started with this. That means I'm going to put a 3 in here. 3 times 3, remember when no sign is given, that means multiplication. 3 times 3 is 9, minus 1 gives me 8. Over here, 3 times, this time 5 is the number that I'm putting in. 3 times 5 is 15, minus 1 gives me 14. 3 times 7 minus 1 is going to give me 20. And then finally, 3 times -1 minus 1, well, 3 times -1 is going to give me a -3. When I subtract 1, I actually get -4. If that's something you don't remember, that is something that we'll go over in class. our sign values and things, how we add and subtract, multiply, and divide negative and positive numbers. All right, so we've done the thing that we set out to do, except we never stated the domain and range. And we know that that's totally easy. The domain is given as the set of values. I'll write -1, 3, 5, and 7 that are underneath the x coordinates or the x value there. And the range is given as the following: -4, 8, 20. I'm going to write it in order. It doesn't really, you don't really have to write it in order, but I'm just doing it because I like it. All right, so -4, 8, 14, and 20. Yeah, that's it. So that's how you make a function table, and that's how you answer that question. Let's look at this next opportunity to learn, or example 2. We're going to use multiple representations. The navigation message from a satellite to a GPS in an airplane is sent once every 12 minutes. So the first thing we're asked to do is to write an equation to find the number of messages sent in any number of minutes. So when I look at this, I feel like I'm totally being given the opportunity to define some variables. So the first one is the number of messages. I'm going to use n. So n will equal the number of messages. And then for this next portion, or the next thing is sent in any number of minutes. Since time deals with minutes, I'm going to use t. So t is equal to the number of minutes. There's no wrong way to define your variable, but it's helpful to do it in a way that's relational. So that's what I'm trying to do here. So n is the number of messages, and let me make that look a little bit nicer. I used the wrong one. All right, so n is the number of messages, and t is the amount of minutes. And they want us to come up with an equation that can really facilitate finding the number of messages given any number of minutes. So if we're looking for the number of messages, what I feel like I'm going to do is start off with n equals. N equals what? How can I relate the number of messages to the number of minutes? Let's go back to the information we were given. We're told that the navigation message for a satellite to a GPS in an airplane is sent every 12 minutes. One message for every 12 minutes. But what if I started off with minutes? What if I had like 48 minutes? How many messages would I have gotten? How would I calculate that? Think about it. If I had 48 minutes, if 48 minutes passed or elapsed, how many messages would have been received by this through this GPS device, right? How many messages? Well, I hope that you guys realize 4. And what did you do to get the 4? You divide it. So that's what we would do with the number of minutes, the t, the number of minutes that we have. So if I had t minutes, let me use this color. If I had t minutes, and I'll try one more time. If I had t minutes, whoa, can't work? Okay, there we go. T minutes, what would I divide the minutes by in order to figure out the number of messages? It would be 12. So n is equal to t divided by 12 is going to be our formula that we're going to use. It's going to be our rule that we're going to use to answer the following questions. So now we're asked to make a function table to find the number of messages once we have 120 or 180 or 240 or 300 minutes elapsed. And then we're going to graph the ordered pairs. So we got a little bit of work to do. So let's get started with making our table. So our table will consist of t values here and our n values here. The values that we're given are t values because we're talking about time. So we have 120, 180, 240, and 300. And now to get the answer, this looks like an H. I'm going to make it more N-like. To get the answer, I'm going to use the formula that I created or that we created to get the answer. So I start off with N is equal to T, which is 120 over 12. Okay, let me do that again. N equals T over 12. And I'm going to just literally plug in each of these into for T to get my answer. So the first N value would be 120 divided by 12, and we get 10. The next one is 180 divided by 12, and we get 15. The next answer right here would be 240 divided by 12, and you can see that we would get 20. Oh, I just lost everything. I lost it all. I'm sorry. All right. Come back, Dion. All right, so we get 20 here, and then finally I would put 300 here to get the last value. 300 divided by 12 is going to give me 25. All right, I hope it was clear and not too long-winded. Let me know if there's anything that I can clarify for you, and I look forward to talking to you soon. Take care. Bye-bye.